Alright, so now we are in chapter 2.7 and we are working with inverse functions. Here are our objectives. I'll let you read through those. Alright, so the definition of the inverse of a function. Let f and g be two functions such that f of g of x is equal to x for every x in the domain of g, and g of f of x is equal to x for every x in the domain of f. So recall that f of g of x is the same as saying fog, and g of f of x is the same as saying golf. Well, what they're saying that if you perform fog, if you do fog and you do golf, and you end up with x in both cases, then f and g are actually inverses. Okay? So this is what it says down here. The function g is the inverse of the function f, and is denoted by f inverse. That's what the -1 is, a superscript of -1. So as I just said, if you work out fog as well as golf, and you end up with x in both cases, then f and g are inverses. Alright, so let's go in our book on page 309. We're going to look at problems 5 and 7. The instructions say find f of g of x and g of f of x, and determine whether each pair of the functions f and g are inverses of each other. So number 5. And we have f is equal to f of x is equal to 5x minus 9. And then we have g of x is equal to x plus 5 divided by 9. So the first thing we need to do is find f of g of x and g of f of x. So remember, with fog, g is plugged into f. G is plugged into f. So let's write out f. So we have 5, and then we have an x right here. Instead of writing the x, you write x plus 5 divided by 9 minus 9. And then of course we can simplify this. So this will become 5x plus 25 divided by 9 minus 9, and that's fog. Now the question is, does this equal x? No, it doesn't. So this is not equal to x, which tells me right now that I know these functions are not inverses. But we're going to go ahead and finish because they wanted us to find golf as well. So let's find golf. G of f of x is going to be, well, it says x, but instead of writing x, remember, now we're going to take f and plug it into g. So f is going to plug into g. So that's going to be 5x minus 9 plus 5 all over 9. Okay, so this simplifies out to 5x minus 4 divided by 9, which also does not equal x. So remember, when determining if they are inverse functions, you perform fog as well as golf. If you end up with x in both cases, then your functions are inverses. We did not. This is our fog, and this is our golf. They are not equal to x, therefore f and g are not inverses. Alright, let's move on to number 7. So number 7, same instructions. Find f of g of x and g of f of x, and determine whether each pair of the functions f and g are inverses of each other. This time we have f of x equal to 3 over x minus 4, and we have g of x equal to 3 over x plus 4. So let us find f of g of x. So remember, the g is plugged into the f. So everywhere we see an x inside of f, we're going to plug the entire g. So we have 3 divided by, and instead of writing the x, you have to write the entire g. So it's 3 over x plus 4 minus 4, and then you simplify. Well, 4 minus 4 is 0, and you end up with 3 divided by 3 over x, which simplifies down to just being x. Here's the side work for this. This is like saying 3 divided by 3 over x. So remember, you do not divide fractions, you multiply by the reciprocal. The reciprocal means flip this. 3's cancel out, and you're left with just x. So that is fog, or f of g of x. Now let us find g of f of x. So you're going to take f and plug it into g. Everywhere you see an x inside of g, you're going to plug the entire f. So it is 3 divided by, instead of writing the x, you're going to write all of f. 3 over x minus 4 plus 4. And then, of course, let's simplify this. Now, this piece right here is the same as saying 3 divided by 3 over x minus 4 plus 4, just like what we did up here. And then, of course, we can clean it up. We do not divide fractions, we multiply by the reciprocal, so this is going to flip, and when it does, the 3 is going to be on the denominator, which is going to cancel with this one, and you're going to be left with x minus 4 plus 4. Minus 4 plus 4 cancels out to 0, and you're left with x. Now, when you perform fog and golf, and you end up with x in both cases, it tells you that f and g are inverses. All right, let's keep going. All right, now let's talk about actually finding the inverse of a function. So the equation for the inverse of a function f can be found as follows. Step 1, replace f of x with y in the equation for f of x. So instead of writing f of x, now you're going to write y. And the second step says interchange x and y. Switch x and y. Step 3 is to solve for y. It has extra information. I'll let you read through this. Okay. Step 3 is to solve for y. It says, actually I'll read it to you. If this equation does not define y as a function, the function f does not have an inverse function, and this procedure ends. If this equation does define y as a function of x, the function f has an inverse. So step 3 is just to solve for y. And then step 4, if f has an inverse function, replace y in step 3 by f inverse. The negative means inverse of x. All right, again, we're in our books on page 309. We're going to look at number 17 as well as number 25. It says, the functions in exercise 11 to 28 are all one-to-one. So that basically means they have inverses. For each function, part A says find an equation for f inverse. And part B says verify that your equation is correct by showing that the composite functions are equal to x. So number 17, we have that f of x is equal to x to the third power plus 2. Okay, so first thing we need to do, step 1 said to instead of writing f of x, now you want to write y. So you're going to have y equals x to the third power plus 2. And then the second step was to switch x and y. So replace f of x with y. That was step 1. Step 2 says to switch x and y. So now it's going to say x equals y to the third power plus 2. And then the third step says, well, solve for y. Solve for y. So I'm going to subtract x on both sides, and subtract 2 on both sides. And I'll have y to the third power equals x minus 2. And then how do you get rid of a third power? You take the cube root. So y is equal to the cube root of x minus 2. And then the last step was to replace y with f inverse. So now it's f inverse of x, the negative sign, the negative 1, is equal to the cube root of x minus 2. All right, let's look at number 25. Same problem, we need to find the inverse of the function. So f of x is equal to 7 over x minus 3. All right, step 1 said instead of writing f of x, now you write y. So y equals 7 over x minus 3. Step 2 says switch the x and the y. So x equals 7 over y minus 3. Okay. And then step 3 says solve for y. So now we want to solve for y. So we're going to do that by adding 3 on both sides. So now we have 7 over y equals x plus 3. Now what I want you to notice that who is underneath this x plus 3? It is a 1. And since y is in my denominator, I need them on the top. You're going to flip both sides. So it's y over 7 equals 1 over x plus 3. It's just a flip. And if you do it on both, if you do it on the left side and the right side, it'll work. So then we need to multiply it by 7 on both sides, and we get y equals 7 divided by x plus 3. And then the last step was, instead of writing the y, now you want to write f inverse. So f inverse of x is equal to 7 divided by x plus 3. Alright, the horizontal line test for inverse functions. A function f has an inverse, that is, a function f inverse, if there is no horizontal line that intersects the graph of f at more than one point. So, to determine if a function has an inverse, the first thing you want to do is draw a horizontal line. So if you're looking at a graph, you want to draw a horizontal line, and then you want to take note of the number of times it intersects the function. So if the horizontal line intersects the graph only one time, then f has an inverse. If the horizontal line intersects the graph more than once, then f does not have an inverse. Alright, examples. Which of the following graphs represent functions that have inverse functions? Well, the first thing we want to do is draw a horizontal line, and then you want to count how many times it intersects the graph. It intersects it twice, therefore f does not have an inverse function. Now let's look at the second one. Again, draw a horizontal line, count how many times the horizontal line intersects the graph. Only one time, therefore f does have an inverse. Alright, let's go in our books and let's look at problem number 29. It says, which graph in exercise 29 and 34 represent functions that have inverse functions? And this is the graph of number 29. Okay, so that's our graph. And what we need to do is draw a horizontal line, and then count how many times it intersects the graph. With this horizontal line, it intersects the graph twice. Therefore, this one does not have an inverse function. So f does not have an inverse. And then number 32. Alright, so number 32, we're going to do the same thing. We're going to draw a horizontal line. Now, where you pick your line is very important. Yes, if I put the horizontal line right here, I will only intersect my graph one time. So be careful where you put it. How about we put it like that? So there's our horizontal line. How many times do I intersect this graph? An infinite amount of times, right? Because this right here becomes a horizontal line itself, the blue, before I put my red over it. So how many times do I intersect the graph? Many times. Therefore, this one also does not have an inverse function. So f does not have an inverse. Alright, so the graph of f inverse is a reflection of the graph of f about the line y equals x. All that means is if you had f and you wanted to graph its inverse, how would you do so? You would switch the x and y coordinates. So if you want to graph f inverse, you would do so by switching the x and y coordinates. Alright, so here's a graph. It says use the graph of f to draw the graph of f inverse. So let us go ahead and go on here and figure out what these points are. So this point is -3, -2. This point is -2, 2. This one is 4, 3. Okay, so if we were to graph f inverse, all we need to do is switch the x and y coordinates for each point. So this point would now become -2, 3. He would come 2, -2. And this one would be 3, 4. So the first thing you want to do is switch x and y in the points in each ordered pair. I'll say points. So in each point, you want to switch the x and the y. And then, of course, you want to plot them. And then plot the new points. As they did so. Now notice at this point in blue, he is -2, -3, just like we said he would be. This one is 2, -2. That matches up. And this one is 3, 4. And that matches up. And if you notice, if we draw the line y equals x, the best we can, then you notice that the graph in red and the graph in blue are inverses of each other because they are a direct mirror of each other. And of course, they did the same thing I just did. All right, let's go in our books on page 309 still. And the last problem we're going to work on is number 41. 41, it says, find an equation of f inverse. So let's write down 41. And we have f of x equals x squared minus 4. And they tell us that x is greater than or equal to 0. This right here is just a restraint or a condition. I'll call it a condition on x. So in order to find f inverse, remember the first step was to rewrite f of x, write it as y. So now you have y equals x squared minus 4. And then the second step was to switch the x and the y. So now you have x equals y squared minus 4. And then you want to solve for y. So we have y squared equals x plus 4. How do you get rid of a square? By taking the square root. So we have y equals the square root of x plus 4. And then the last step was to replace y with f inverse. So f inverse of x is equal to the square root of x plus 4. So f is equal to x squared minus 4, and f inverse is the square root of x plus 4. Okay, and then the second thing they wanted us to do was graph f and f inverse in the same rectangular, they wanted you to graph f and f inverse. I'm going to let you graph them on your calculator. So with your graphing calculator, this is part B. So this is using the graphing calculator. Remember how we talked about it before. The first thing you want to do is go ahead and hit y equals. So press y equals. Remember, that's a button. It's on the top left. So the top left, you should see y equals. Go ahead and press it. And then input f of x. And then on the next line, go ahead and put f inverse of x in there. And then if you need to, check your window. So check your window to make sure you have the default. Remember, your default had an x min of -10, a x max of 10, an x scale of 1, a y min of -10, a y max of 10, and a y scale of 1. Remember, that was your window. And then, of course, go ahead and hit graph. And you can verify that f and its inverse are mirrors of each other about the line y equals x. Alright, the last thing they want us to do is use interval notation to find the domain and the range of f and f inverse. So actually, let me move some of this up. Let's use blue. So step 4 was to go ahead and hit graph. Alright, so finding the domain of f of x. Well, f of x was equal to x squared minus 4. And remember, the domain is the x value, so you're looking for a denominator or a square root. Since we do not have either one of these, the domain of f is just all reals. It's a polynomial. It's a polynomial function, so it's continuous everywhere, and its domain is all reals. Its range, or the y values, what can you get out of this? Well, hopefully at this point you're looking at your graph, and you should see that you get the entire real line out of f. Now let's deal with f inverse. So f inverse of x was the square root of x plus 4. First thing we want to do is the domain, right? Well, I have a square root, which means its inside has to be set greater than or equal to 0. And then I get to solve for x. So x has to be greater than or equal to -4. So its domain is going to include -4. That's what the brackets are for. And it goes all the way up to infinity because it says greater than. Remember how the number line looked. Here's -4 on the number line. It has a bracket opening to the right because x is greater than. And then you shade all of this up here. So -4 to infinity. And then the range are all the values you get out of this. Well, we know when we graph this, so let me graph it as well so I can be looking at it at the same time. Alright, so when we look at our graph, I have to change my window. Okay, so when we look at our graph, we see that in our range, our y values, we're going to have 0 and positives, right? Because remember, this is a square root. We're only going to get 0 in the positive number, so the range includes 0 to infinity. Alright, so that concludes the video for 2.7. Let me know if you have any questions.